Okay, this is a continuation from the previous video. It was getting a bit long, so I've sort of chopped it up. In the last video we saw the sine graph, we saw the cos graph, and we saw where they came from in terms of the unit circle. I want to now use both of those graphs to show you where the tan graph comes from. You remember a couple of videos ago we saw that the tan function is the same as the sine function divided by the cos function. So if I do sine divided by cos, I get tan. So let's have a look. I've got my sine graph here, I've got my cos graph. So let's have a look. So to begin with, we can see I've got 0 divided by 1. 0 divided by 1 is 0. So I know it's going to go through 0. Then, as theta starts to increase, sine starts to increase, and cos starts to decrease. So my numerator is getting bigger, my denominator is getting smaller. So if I'm dividing a bigger number divided by a smaller number, my answers are going to get bigger and bigger and bigger. In fact, it gets to the point where I'm dividing by some extremely small numbers here. So my tan is going to get really large, really big. You might even notice that I've not marked on here any values on my y-axis. With the sine graph and the cos graph, I've marked on 1 and minus 1. I've not marked on any values on my tan graph because it gets bigger and bigger and bigger. In fact, it gets bigger without limit. The graph is going to actually tend off to infinity. Now, what happens at 90? So at the moment I know my graph starts off quite small, but then it gets bigger and bigger and bigger and bigger. At 90 degrees, cos 90 is 0. And I can't do 1 divided by 0. I can't divide by 0, it's undefined. The laws of mathematics will break down if we try to divide by 0. So tan is not defined when theta is 90 degrees. So what we have there is what's called an asymptote. An asymptote is a line, usually we draw it on as a dotted line. It's a line that your graph is going to get closer and closer towards, but never actually touch. It's not going to touch it, but it's going to get closer and closer towards it. So my tan graph starts off small, but then gets bigger and bigger and bigger and bigger, and then it explodes off and tends off towards infinity like that. The function is not defined at 90 degrees at all. Okay, what happens after 90 degrees? Well, we can see my sine starts off at 1, and my cos starts off very small and negative. So I'm dividing 1, or just below 1. I'm dividing a big number divided by a very small negative number, which is going to give me a very big negative number. Then, as I keep increasing, my numerator gets smaller and smaller and smaller, and my denominator gets bigger and bigger and bigger, but negative. So when I'm dividing a smaller number divided by a bigger number, I'm going to get a smaller number. So what happens is, I get the reverse process of what's happened here. As in, it starts off down here, and it gets smaller and smaller and smaller, and it's going to get closer towards 180. I've not drawn that very well. Let me try and draw it the other way. Like that. So again, it's getting closer towards the asymptote. So it doesn't touch the asymptote. The tan graph has what's called a discontinuity at 90 degrees. You see the graph is not continuous. It does this jump. It jumps from being up here where it's really large and positive to down here where it's really large and negative. if you want to check down your calculator, if you type into your calculator tan 89 and then type in tan 91, and you'll see one of them will be very large and positive and the other one will be very large and negative. So it's got this discontinuity. And then it goes up to 180 where it is 0 because at 180 sine is 0, cos is -1 and 0 divided by -1. Then above 180 degrees, so now we can see here the sine is negative but also cos is negative. So if I divide a negative divided by a negative, I'm going to get a positive. So in actual fact here, the graph will be positive and it's going to follow the same pattern that we had before. I will have another asymptote at 270 degrees because cos 270 is 0. You can see that here. And I can't divide by 0, so there is another asymptote at 270 degrees. And the final part of the graph will follow the same pattern that we've seen previously and be like that. So there's the tan graph. Again, lots of symmetry within this graph, just as there was in the previous examples of the sine and the cos graph. The tan graph, if I wanted to work out tan 150, let me mark that on. 150 is here. So I'm looking at what's that value there. Well, I can see this is 30 degrees away from 180. That's 30 degrees here. So that's going to be the same as 30 degrees here, but negative. So that's going to be equal to minus tan 30, which is equal to minus root 3 over 3. Tan 225. 225 is about here, roughly. And that's 45 degrees above 180. So I'm looking at this part here. So 45 degrees above 180, it's going to be the same as 45 degrees above 0. So it's equal to tan 45, which I know is 1. And then finally, tan 300. 300 is about here. So I can see it is negative. It is 60 degrees away from 360. So this is going to be the same as 60 degrees away from 0, but negative. So it's going to be the same as minus tan 60, which is minus root 3. And there we go.